Hi, this is Sharmin Akter. The topic of my presentation is New Order CNC based nanocomposites in polymers matrix. For the research study, the paper that I read was the title Supermolecular Engineering of Hierarchically Self-Assembled Bio-Inspired Cholesteric Nanocomposites Formed by Cellulose Nanocrystals and Polymers. The Zhu et al. Published this paper in ACS Applied Materials Interfaces Journal in 2016. Specific, specific scope of the study is a new hierarchically self-assembled Cartesian mimetic cholesteric nanocomposite can be co-assembled in polymers matrix in the design and development processes. The former order CNC-based nanocomposites with this new hierarchical molecular engineering allow a remarkable mechanical behavior and achieve the new accessible range in bio-inspired design. The key question is what polymer and CNC nanocomposites materials are based in bio-inspired designs based on their composition, fractions, mechanical properties, etc. For the methodology, the authors used Ashby method. Different compositions of polymer CNC crustacean mimetic nanocomposites has been reported in the Ashby plot. This chart proves which material composition is best to select for the desirable bio-inspired design compared to the previously produced material. The material performance indices used are Young's modulus, tensile strength, strain to failure, and work of fracture. The authors used the materials or process surveyed was the hydrogen bonded copolymers can be co-assembled with CNC, which is isolated from Whitman filter paper. Such hierarchical crustacean mimetic nanocomposites materials are surveyed based on photonic properties, soiling response, and tensile behavior for different fractions, comparison of Young's modulus, tensile strength, strain to failure, etc. The key results from the study. Here the table shows an overview of copolymer that is prepared by raft polymerization. Also, the plot shows the influence of the UPY on the mechanical properties for different fraction of CNC. A consistent increase of stiffness, yield points, and tensile strength can be derived from this plot. The expansion of the properties goes along with a shortening of the maximum elongation. In the less reinforced materials, the compositions of polymer and CNC is about 40 to 60. They found the UPI content controls the elastic and inelastic properties. Another key results from the study, based on the literature values, the authors plot the Young modulus versus strain to failure in an Ashby plot to provide an instructive comparison between stiffness and ductility, which is an indicator for toughness. The best materials combining stiffness and ductility are located on the top right in this plot. The authors showed that the former order CNC based materials with the stiffness up to 2 gigapascal and a strain up to 3% can allow a remarkable behavior and achieve the new accessible range from highest inelastic deformations, which is up to 13%, to the most increased stiffness, which is reaching up to 15 gigapascal. The key conclusions from the research paper. The HB plot shows the Young modulus versus strain to fracture of bio-inspired designs. The new design shows higher mechanical properties for different compositions of polymer and CNC than previously produced similar compositions such as epoxy, PVA, PEZ, etc., whose properties can get from the CES EduPack database. The resulting materials are lightweight and perform unique combinations of strength and toughness. To promote sustainable approaches toward bio-inspired nanocomposites, it is essential to find renewable, globally abundant constituents that can be isolated with great ease at low costs. For this one, plant-derived nanocellulose bio-nanoparticles are emerging as critical building blocks for such nature-based mechanical high-performance materials because they are based on one of the stiffest material, crystalline. Personal opinion on this paper: the paper is innovative and convenient, which could be helpful to enhance future adaptive design manufacturing in bio-inspired applications. However, in this paper, they could provide more supporting informations and relevant plots. Thank you.